In this video, let us do a calculation for comparison of coefficient of viscosities of two given liquids by capillary flow method. Usually, we used to find the coefficient of viscosity of a liquid by this method. The same technique can be also used for comparing the coefficient of two different liquids. Generally, the easily available two liquids in our laboratory is water and kerosene. Even you can compare the coefficient of viscosities for water and coconut oil, or coconut oil and kerosene. So the easily liquids available in our laboratories are water and kerosene. So the time of flow of liquids is first noted. For the burette reading of 0, for water the time of flow is 0. For every 55 cc the timings has been noted for water and kerosene. So the time of flow for water for 50 cc is around 6 minutes 49 seconds, whereas for kerosene is 17 minutes 21 seconds. So from this comparison itself we can identify kerosene has more viscosity than water. So all these we have time of flow we have it in minutes and seconds. First let us convert this minutes and seconds into seconds. So we all know 15 seconds first for liquid one, that is water. For 5, the burette reading of level 5, the time taken is 15 seconds. For 10 it is 33. For 15 it is 59. For 20 range the time taken is 1 minute 33 seconds. So 1 minute is 60, 33 seconds. So 60 seconds plus 33 is 93 seconds. Similarly for 25 it is 2 minute 14 seconds. So it is 120 plus 14 is 134. So we have to convert till 50. For 50 the time taken is 6 minutes 49 for water. So 6 minutes is 6 into 60 is 360. 360 plus 49 will give us 409 seconds. In the same way, let us do the conversion for kerosene. For 5 it is 43 seconds. For the burette level of 10 it is 1 minute 33 seconds. So 1 minute is 60 and 33 seconds. So it is 93 seconds. In the same way, convert everything into seconds. For 50 level, burette level, the time taken by the kerosene is 17 minutes 21 seconds. So for 17 minutes, 17 into 60 is 1020 plus 21 seconds is 1041 seconds. So by this way we have converted all the minutes and seconds into completely into seconds. Now let us find the time of flow for every burette range. So 0 to 5 the time taken by the water to flow is 15 seconds. That is subtracting the time taken for the previous level. For 15 to 10, see it is 33 minus 15. 33 minus 15 is 18. For 10 to 15, so it is the previous level. 15, the time taken for 15 level to minus 10 level. So you get 26. So in the previous table you can see. So for 15th level it is 59 and for the previous level it is 33. So 59 minus 33 you get 26. In the same way you calculate till 45 to 50, that is 71. For the kerosene for 0 level it is 0 and for the 5th level it is 43. So 43 minus 0 it is 43. For 5 to 10 it is 9. Let us check in the previous one. So it is 93 minus 43. 93 minus 43 gives us 50. So by this way we have calculated T1 and T2. In our formula we need what is the value of T1 divided by T2, that is the time of flow of liquid for water divided by time of flow of liquid for kerosene T2. So it is 15 divided by 43 gives 0.349, and then the second value 5 to 10, 18 divided by 50 gives 0.36. and third value is 26 divided by 74 gives 0.351. In the same way, we can calculate till this 45 to 50 range. So for 45 to 50 range, we got 71 by 152, which is 0.467. See, totally we have 10 readings. Out of these 10 readings, all the readings are almost closer to 0.35. 3 readings which are highlighted in red color are deviating from the 0.35. So 0.415, 0.427, 0.467, which I have highlighted in red color, are eliminated while taking the average. So I have added the remaining 7 T1 by T2 and it comes out to be 2.53, and dividing it by 7 we get 0.361. If in case if all the 10 values are coming closer to a constant value, then you have to add all those 10 values and divide it by 10. So here 3 values are deviating from a constant value, so I have eliminated while taking the average. So we have got T1 by T2 equal to 0.361. Next, we have to compare the densities of the two liquids by Hart's apparatus. So densities rho 1 by rho 2. Again, using the Hart's apparatus, the level of reading is noted for water. Limb level is 4.6 and beaker level is 33.5. So the height difference H1, by subtracting these two values, we will get the height difference H1, which is 28.9. For the second height difference, second value 4.8 and beaker level is 32. Subtracting these two, you will get 27.2. At the same time, for the kerosene, the limb level, when the water limb level was 4.6, the kerosene limb level was 5.2 and the beaker level was 41.2. So subtracting the kerosene values of limb level and beaker value, we get 36. And for the second set of value, 5.3 for limb level, 39.3 for beaker level. Subtracting these two level, you get 34. So in the same way, you do it for all the 5 readings. Now you will get H1 and H2. Now we need to find out rho 1 by rho 2. Rho 1 by rho 2 is H2 by H1. So H2 is 36. 36 divided by 28.9 gives 1.245. And the second value is 34 divided by 27.2 gives 1.25. In the same way, you can calculate 5 H2 by H1. So in this last column, you could see all the 5 values are almost closer to each other, 1.2. So you can add all the 5 readings and divide it by 5. You will get rho 1 by rho 2 equal to 1.245. So we have got what is rho 1 by rho 2 and T1 by T2. The calculation for comparison of the two viscosity of two liquids is eta 1 by eta 2 equal to rho 1 by rho 2 into T1 by T2. So the rho 1 by rho 2 we have just now calculated, which is 1.245, and T1 by T2 is 0.361. So when you multiply these two, you will get 0.449. So eta 1 by eta 2 equal to 0.45449. This we got it by experimental calculation. Theoretically, we know the constant value for the coefficient of the standard value for the coefficient of viscosity of water is 0.0008 to 0.001. So I have taken it as 0.008 Newton seconds per meter square. And the same eta for kerosene is 0.002. So when you do eta 1 by eta 2, you get 0.008 divided by 0.002 will give you 0.4. So eta 1 by eta 2 is 0.4. So finally we can interpret, or we can compare our results. So we have found the coefficient of viscosity of the two given liquids, and the ratio is, we have compared it and the ratio is found to be, theoretically we have got eta 1 by eta 2 as 0.4, which is almost, which is comparative with our experimental value of eta 1 by eta 2 equal to 0.449. So theoretical value is 0.4 and experimentally we have got it as 0.449, which is almost closer to this theoretical value predicted.